Astronomy, the solar system, featuring the discovery of the planet Pluto.
This program was developed in consultation with Dr. Clyde W. Tombaugh, Professor Emeritus of Astronomy at New Mexico State University. Dr. Tombaugh is the scientist who made the remarkable discovery of the planet Pluto. If on a clear night you pull up your chair to a south-facing window, turn out the lights and look at the stars, they'll look something like this. And if you sit and watch for a while, you'll see that the rotation of the Earth makes the stars appear to move from east to west, that is, from left to right across your south-facing window. If you come back to the window about a week later and about 30 minutes earlier, you'll see that the star positions are the same as they were the week before. All that is except for one bright object. We'll compare the pictures taken a week apart by blinking back and forth between them so that you can see that one object has moved. In the first picture, the bright object was on the left side of the window, in this position. But a week later, it has moved to the center as we see it now. Throughout history, people have recognized that a few bright objects seem to wander back and forth among the stars. The ancient Greeks called these moving objects planetes, which was their word for wanderer. If we change the Greek letters into equivalent English letters, we have, from which we get our English word for these bright objects that appear to wander in the nighttime sky. They are called planets. Throughout this presentation, I will ask questions so that you may check to see if you understand what we've covered so far. Let me ask one now. From what word does the name planet come? Yes, the ancient Greeks called these bright objects wanderer, from which we get our word planet. They knew of 5 planets. Because the motion of the planets appeared mysterious, the Greeks named the planets after their gods and thought they had an influence on people's lives. Mercury is the planet named after the messenger of the gods. It is about 1/20th the size of the Earth and is seen as a brilliant object in the twilight sky. It is the planet nearest to the Sun, and from the Earth always appears close to the Sun. Earth-based telescopes show only faint markings on Mercury, but photographs sent back from passing spacecraft show a heavily cratered surface similar to our Moon. Mercury has only a trace of atmosphere and no surface water. The daytime temperature is greater than that of boiling water, and at night the temperatures are below freezing, an extreme temperature variation. The ancient Greeks, besides naming the planets after their gods, gave them symbols. These symbols are still used as shorthand by astronomers. This is the astronomical symbol for the planet Mercury. The planet Venus, between Mercury and the Earth, is named after the goddess of beauty. Venus sometimes appears with phases like our Moon, and so is often seen as a crescent in the evening or early morning sky. Venus is covered with thick clouds composed mostly of carbon dioxide. This carbon dioxide atmosphere traps the sun's radiation like a greenhouse, and so the surface temperature is many hundreds of degrees. It is very hot and dry on the surface of Venus. Radar measurements of the surface show that Venus rotates on its axis in a direction opposite to its revolution about the Sun. This is called retrograde rotation. The The astronomical symbol for Venus is a circle with a cross at the bottom. The planet Mars is named after the god of war. Its atmosphere is thin, and because we can see its red surface from the Earth, it is known as the red planet. Mars, like Earth, has polar caps that grow and shrink with changing seasons. Earth-based observers once thought they could see a fine network of canals leading from the polar caps to other parts of the planet, giving rise to the speculation that there could be life on Mars. Photographs taken from spacecraft disclose that there are no canals, but do show inactive volcanoes, one more than 15 miles high, and canyons, one large enough to stretch across the entire United States. Experiments on the Viking spacecraft that landed on Mars lead us now to believe that there is no life on Mars. Mars has two small satellite moons named Deimos and Phobos, meaning panic and fear, appropriate companions for a planet named after the god of war. This is the astronomical symbol for Mars. Which planets orbit between the Sun and Earth? Right. Mercury and Venus are the first two planets in our solar system. Jupiter, the largest planet in our solar system, is named after the principal god of Greek and Roman mythology. Jupiter has at least 14 satellites, 4 of which were discovered by Galileo when he first looked at it through a telescope. Using a small telescope or even a pair of binoculars, you can see these moons of Jupiter as they orbit the planet, and can often see the faint band structure and the famous red spot in the planet's atmosphere. Jupiter has more than twice the material of all the other planets together in our solar system. Several Earths would easily fit within the red spot. Although the light we see from the planet is reflected sunlight, astronomers using radio telescopes have discovered that Jupiter emits energy of its own. The astronomical symbol given to Jupiter looks something like the number 4. Saturn is named after the god of seed sowing. The planet Saturn is surrounded by a magnificent ring system made of pieces of ice, perhaps like millions of orbiting snowballs. The ring system is a beautiful sight when seen through a telescope. Saturn, although nearly as large as Jupiter, is much lighter and would float in an ocean if one big enough to hold it could be found. Its average density is less than that of water. Saturn must be composed mostly of hydrogen and helium, the lightest elements, and probably does not have a solid surface as do the 4 terrestrial planets, Mercury, Venus, Earth, and Mars. Like Jupiter, Saturn has many satellites. 1. Titan is very interesting to us because it has an atmosphere and is about the size of Mars. We wonder if there could be life on Titan. Saturn's astronomical symbol looks like this. Which of the following is farthest from the Sun? Yes, it's Saturn. Although much of what we know of these 5 planets, Mercury, Venus, Mars, Jupiter, and Saturn, is known because we have telescopes and spacecraft with which to study them, the ancient peoples didn't have these tools and could only marvel at the bright objects making their way through the nighttime sky. They thought the planets, as well as the sun and the moon, influenced their daily lives, and they named the days of the week in their honor. Different languages have different sounding names for the days of the week, but if we compare 2 languages, say English and Spanish, we'll be able to see the meaning of their names more clearly. Sunday, domingo in Spanish, is the sun day. Monday, or lunes, is the moon day. Tuesday, martes, is the Mars day. Wednesday, the Spanish miércoles, is Mercury day. Thursday, Jueves, is Jupiter Day. Friday, Viernes in Spanish, is Venus Day. Saturday, Sábado, is the Saturn Day. It wasn't until 1781, more than 150 years after Galileo used a telescope to view the sky, that the planet Uranus was discovered. When William Herschel, an astronomer in England, first observed the object, he thought it was a comet. After many observations, the orbit was calculated, and it was found that, although smaller than Jupiter and Saturn, it was a giant planet that circled the Sun every 84 years. The discovery of Uranus, named after the father of Saturn, excited people throughout the world. Astronomers studied Uranus closely for many years and eventually recognized that its orbit was somewhat irregular in a way that could not be explained by the attraction of the Sun and the known planets. This is the astronomical symbol for Uranus. What was the planet Uranus first mistaken for? Very good. In the early 1800s, astronomers began to suspect that the irregularities in the orbit of Uranus were due to the existence of another planet beyond Uranus, a trans-Uranian planet. In 1845, a young Englishman named John Adams calculated where this unseen planet should be found and asked the astronomer royal to search for it, but he did not immediately do so. Meanwhile, a French mathematician, Leverrier, made a similar calculation independently and sent his results to the Berlin Observatory. That very night, within 1 degree of the position predicted by Adams and Leverrier, a previously unknown planet was found. The planet was named Neptune after the god of the sea. Neptune is far from the Sun and too faint to be seen from Earth without a telescope, even though it too is a giant planet with a diameter 3.5 times that of Earth. The astronomical symbol for Neptune is this. Thus far, we've talked about 8 planets, including the Earth. Some of these are terrestrial planets, which means Earth-like. They are about the same size as the Earth and have a firm surface. Others are much bigger than the Earth and are called the giant or Jovian planets. That's right. Jupiter, Saturn, Uranus, and Neptune are the giant planets, while Mercury, Venus, Earth, and Mars are the terrestrial planets. By the beginning of the 20th century, most astronomers had concluded that the discovery of another major planet in our solar system was unlikely and had turned their attention to other investigations. There were 2 astronomers, however, who persisted in their belief that a trans-Neptunian planet existed. One of these, William Pickering, was a professional astronomer. He calculated a number of possible orbits for his unknown planet, some close to Neptune and some much farther from the Sun. His predictions did not lead to the finding of another planet. The other, Percival Lowell, was an amateur astronomer who began the Lowell Observatory at Flagstaff, Arizona, in an attempt to prove that Mars had intelligent life, as evidenced by the network of markings on Mars which he thought to be canals. In 1915, he published his calculations of the orbit of Planet X, but with his death a year later, search for the planet was discontinued. The search for Planet X was resumed when in the spring of 1929 a new telescope was installed at the Lowell Observatory. It had been carefully designed to photograph relatively large areas of the sky. Such a telescope is called a wide-field telescope. A wide-field telescope covers large segments of the sky with fewer photographs than a normal telescope would take. The glass plates on which the photographs were taken were 14 by 17 inches in size, and a single plate could contain hundreds of thousands of star images. When comparing 2 photographs of the same part of the sky, so many images made it very difficult to find one that might have moved and thus might have been a planet. To make the search easier, Lowell Observatory had installed an instrument called a blink comparator. Do you remember the window we looked through at the first of this program? We compared two views of the same part of the sky taken a week apart and found that one of the objects had moved. Now let's see how that principle can be used with a blink comparator to find a possible planet. This is what 1 square inch of a large photographic plate would look like if it were seen through a magnifying microscope. If we looked at another such view taken 1 week later, and if only one image position was different, then it would look like this. All the images in this second view are exactly like those in the first photograph except for one. With so many stars, it is almost impossible to tell which one is moved by just looking at the photographs. Suppose, however, both photographs are placed on a blink comparator and carefully aligned. If you look through the magnifying eyepiece and blink back and forth between the two photographs, an object which is moved appears to jump back and forth like this. A blink comparator is a very necessary instrument for detecting unusual motion among the stars. What two instruments did the observatory have to begin the search for Planet X? Yes, a wide-field telescope and a blink comparator. Even more important than having the right equipment to search for Planet X, Lowell Observatory needed a careful observer who was willing to work long hours and would quickly learn to operate the delicate equipment. Just such a person was Clyde W. Tombaugh, who came to work at the observatory in January of 1929. Using a small telescope at home in Kansas, Clyde Tombaugh had observed and drawn Mars and Jupiter. These drawings so impressed the director of the observatory that he offered Tombaugh the job of observer, a job he promptly accepted. So it was in the spring of 1929, with the proper equipment and a promising observer, a new and thorough search for Planet X was begun. Let's have Dr. Tombaugh tell us about it.
It was winter when I arrived at Lowell Observatory in Flagstaff, Arizona in 1929. Flagstaff is 7,000 feet above sea level, and even though in Arizona, the winters are often severe and with very cold nights and lots of deep snow. Although the nights were cold and the hours long, I was a young man and thrilled to have the opportunity to participate in the search for Planet X. I was anxious to do a good job and pleased to be entrusted with such an important assignment. The plane in which the Earth orbits the Sun is called the ecliptic. All the then known planets orbited the Sun in nearly the same plane, and I would take photographs along the ecliptic to see if another could be found. Because the axis upon which the Earth rotates is tilted with respect to the plane of its orbit around the Sun, the trace of the ecliptic against the background of stars appears to observers on Earth to wind its way in and out among groupings of bright stars. Groupings of stars are called constellations, and those lying along the ecliptic are called the zodiacal constellations. Since the known planets are always seen in this portion of the sky, it was there, among the zodiacal constellations, that I began to search for Planet X.
Why search near the ecliptic for Planet X? Yes, all the other planets are near the ecliptic.
It was April 6, 1929, when the search was begun by photographing in the constellation Gemini. Moving eastward along the ecliptic, I reached the constellation Sagittarius in June. I had now taken nearly 100 photographic plates of the sky along the ecliptic. But only a few of the plates had been examined or blinked, under the blink comparador to see if Planet X had been photographed. The planet for which I searched was expected to be several times the size of the Earth, perhaps like Uranus and Neptune, but quite a bit farther from the Sun, and so very much fainter. When the moon is in the nighttime sky, photographs that are exposed for any length of time tend to collect too much light. The photographs then have a foggy appearance and faint objects cannot be seen. On those nights having moonlight, I did not photograph the sky, and so had many nights on which I did not observe. In the middle of June 1929, because only a few of the many photographic plates had been checked in the blink comparator, I was assigned the additional job of inspecting these millions of star images to see if Planet X was to be found among them. This was a huge task that made me solely responsible for finding the planet if it was there. I then had not only to take the photographs, but to spend thousands of hours blinking them.
What was the other job Dr. Tombaugh started at this time? Of course, blinking the plates.
I spent the remaining months of 1929 both photographing the long ecliptic at night and blinking plates during the day. On the morning of February 18, 1930, I placed a photographic plate I had taken on January 23rd on one side of the blink comparator. A small section of the plate looks like this. On the other side of the blink comparator, I placed another plate of the same region in Gemini, but photographed 6 nights later. That same small section on the second plate looked like this. I had found that alternating views, blinking them, several times a second was the best speed to detect shifting positions. As I began to blink a section, it appeared like this. I became very excited when I saw that an object was shifted about the right distance for it to be beyond the orbit of Neptune. It was fainter than I had expected. I blinked the plates again to make sure it was really there. I then checked to see which plate had the eastern position and which was further to the west. A distant planet opposite to the Sun will appear to have retrograde motion among the stars. That is, move opposite to its direction in orbit because the Earth is circling the Sun more rapidly. On the earlier plate, the image was here. On the other plate, the image appeared to move to the right, which was west, just as it should be for a distant planet in this position. Then I hurried to tell the others of my discovery.
This appeared to be the planet for which they were searching because correct.
It was February 18th, 1930, that I discovered the planet. But many things needed to be done before it could be announced. We took photographs on following nights so as to be sure that the newly discovered object's motion conformed to that of a trans-Neptunian planet. We also made visual observations of the planet to see if the image was a disk, as those of the other planets. But it was too distant and too small to show a disk. We were surprised to find its color to be more or less yellow, like that of the terrestrial planets, rather than blue like that of Neptune. Not everything about Planet X was as we expected. The discovery of the new object was announced on March 13th. The newspapers throughout the world featured the story of the discovery. The 9th planet of our solar system had been found.
the date of the announcement of the discovery was the year.
Almost immediately, suggestions for the name of the planet began to pour into Low Observatory, thousands of them. We finally chose the name of Pluto. Pluto was the god of the lower world. Because of the planet's remoteness, the darkness of then the world seemed appropriate for this distant planet. The first two letters in the name Pluto were also the initials of the founder of the observatory, who had predicted the planet to be near the location where it was found. It is appropriate that Percival Lowell should be remembered in the name of the planet. Accordingly, the astronomical symbol chosen for the planet Pluto was this combination of the letters P and L.
What do the letters P and L of Pluto's astronomical symbol stand for? That's right, Percival Lowell was honored in Pluto's symbol.
As Pluto became more frequently observed, its path was more precisely calculated. It circles the Sun every 248 years at an average distance of 39½ astronomical units. That is 39½ times the average distance of the Earth from the Sun. The orbits of all the planets are slightly oval in shape rather than perfectly circular, and Pluto's was more so than any of the others, and sometimes a narrow part of its orbit brings it into a distance of only 29 astronomical units, a little inside that of Neptune. Further, Pluto's orbit is tilted with respect to the ecliptic plane by 17 degrees, and so Pluto ranges from far above to well below the plane of the Earth's orbit. Because Pluto is such an unusual planet, some astronomers speculated that it might be a satellite like our moon that escaped from another planet. In 1978, the astronomer James Christie of the United States Naval Observatory noticed that although the magnified image of Pluto often looked like this, the image of Pluto sometimes takes this shape. He knew that two objects that were so close together that they could not be resolved could, when properly aligned, give a distorted image, and he cleverly deduced that this distorted image was of Pluto and a satellite moon. This discovery in 1978 by Dr. Christie, that Pluto had a moon, now named Charon, is accepted by most astronomers as solid evidence that Pluto is indeed the ninth planet of our solar system.
Do you know the name of Pluto's satellite? Good. The discovery of the planet Pluto in 1930 by Dr. Clyde W. Tombaugh is now recorded in history as one of the great discoveries of the 20th century. The remarkable story of the diligence and perseverance that led to its discovery is a tribute both to its discoverer and to all the others who searchingly explore our universe. Many additional facts and interesting stories connected with the discovery of Pluto can be found in the book that accompanies this program.